drawn, the radius of the circle is 9 centimeters, and the angle inside the sector at the center is 240. The circle is folded to make a cone by pushing the two radii together. This shape, as you remember the major sector, it becomes a cone when you push the two radii together. Calculate the surface area of the cone, okay, including the base. Okay, so first and foremost, for the actual cone, so the area of the cone we know is the following. We know that this is the just by looking at this major sector. So the major sector is going to be the following, which is, so because 240 is the angle we have, we're going to be using this as a fraction. So 240, we got to have 240 degrees out of 360 because the whole circle is 360. So this is the fraction we're going to be using. This is how much part of the circle we have. So we're going to multiply it by pi r squared. So pi times r, which is our 9 squared. And when we do that, this should give us the following. Let's get the calculator out. Okay, the calculator is not here, so let me just do it on my calculator here. 240 divided by 360 times pi times 9 squared. That should give us area of 169.65 centimeters squared. Okay, so that's our area of the cone itself. Now, to find out the radius of the cone, so when this major sector becomes a cone, we have to really understand what that really means. So our whole circumference of this major sector, so the circumference of major sector is going to be, in terms of fraction, it is 240 over 360, because that's how much we have of a circle, times 2 pi r. So this is our circumference of the major sector. It's going to be equal to the 2 pi r. So we can call this 2 pi. So the r itself over here is 9. So let's do times 9. And we have the r that we need to really find out. So this is the missing thing that we need. So because we know the circumference that is on the outside of the, let me just use my pointer instead. We know that the circumference of this major sector would be equal to the circumference around the cone. So that's how I got this. So let's move on. Let's work this out. Okay, so when we simplify this, we should get 340 divided by 360 times 18 pi, 2 pi r. So what we can do to both sides is we can divide both sides by pi, because we've got multiplication there, we can say that everything is multiplied by pi, and same thing in this section over here. So divide everything by pi, we should get the following. I'm going to carry on working here because of lack of space. So I'm going to get the following: 240 divided by 360 times 18 equals 2r. So now, if I were to work this out on a calculator, I would do the following: 240 divided by 360 times 18 gives me 12. So this gives me 12 with 2r. So to get rid of the 2 from the r, I need to divide this by everything by 2. This cancels out, and my radius of the the cone is 6. So 2 divided by 12 gives us 6 centimeters. So for me to now find the area of the circle is quite simple. The area of the base of the cone itself, so which is pi r squared. Pi times r squared. This is the area of the circle. And so all I'm going to do is plug r into there, substitute it. So I'm going to have now pi times 6 squared, which gives me 36 pi, which is also equivalent to centimeters squared, sorry, which is also equivalent to 6 pi is 113.1 squared. So now we have the two different surfaces, 113.1 and 169.65. So in total, we're going to add, so total surface area equals 169.65 plus 113.1 gives us the following. So let me just change the color so you can see that this is the main thing that we work out. This color, brighter. I could do that plus 169.65, and that gives me a total surface area of 282.75 centimeters